Happy Friday. Good to see everybody again. According to my clock, I'm counting down to like 1 minute to get started. So, what I'd like to do is kind of play a little catch up on where we were at and where we're going today. So, the first session we were discussing terminology, right? Understanding what a wire harness assembly is, getting an idea of the components within the wire assembly. And then finally, we moved our way back into, hey, Nick, can you hold on a second? Then finally, we moved our way back into the repair process of what we can do on the vehicle, right? And then again, what is going to occur off the vehicle. So we're going to dig in a little bit deeper on the repair portion of the wire assembly. And we're going to talk about splicing because it's a big part of the job, right? We're talking about removing damaged circuits, replacing damaged circuits. So as you can tell, we brought out the big guns today. There's a lot of heavy equipment here that I'm just going to touch basis on, and then we're going to demonstrate some soldering techniques. Also, what's the industry has now moved toward in regard to soldering, manufacturing wise, not so much in the field. So let's go ahead and get started. Uh, what is a splice? A splice is the joining of two circuits or wires to maintain continuity and again reduce the amount of interference, or better yet, try to maintain the integrity of the original wire. So we're joining two circuits. There's a couple of different ways that you'll see this in the industry, and I'm going to kind of walk my way left to right here. The first, let's look at some lugs, some butt splices. This is a very good indication of one. This is pretty big stuff here, and primarily used for battery cable, right? This is a nice aught-gauged wire assembly, negative cable, right? Black, you could probably count to that. And also the stranding. You could tell there's a lot of strands in here, giving it a great deal of flexibility. We spoke a little bit about that, the need to have flexibility in a wire harness assembly because of vibration, movement, installation, removal, etc. So really what we're looking at then is taking our barrel, this is called an open barrel butt splice, and it simply slides over the wire strands. Now the key is not to overly twist the strands. You want to keep it in the condition or the shape it was in when it was manufactured. And again, the right size barrel for the right size splice. So here we go. What's nice about this is you'll notice you could have an indication or inspection hole here, which makes sure that you have the correct depth or engagement into the barrel. Other thing to keep in mind, you don't want too much insulation exposed, right? It just opens you up to corrosion. What helps though is shrink tubing, right? Being able to come back over the barrel and the wire with at least 1.5 times the diameter of the wire extending beyond the barrel or butt splice. And there you go. You'd have something that would look like this. Very difficult to do in the field. I'll give you an idea of the equipment that might be needed for that. It would be something along these lines, right? This is a pretty big crimper here. And to get a barrel like this to crimp to any type of OEM specification, you're going to need leverage. I can't demonstrate that using this tool. I just don't have the physical strength to be able to close it. So I would pass this job on to somebody else. But again, just to let you know, there is a field application for this, okay? However, we move our way into a press, right? A pneumatic system that comes with a series of dies or die sets, interchangeable. So we can go ahead and design this, or I'm sorry, swap over the die set to match the type of barrel we're going to be using or the type of terminal we're going to be using. I'm not going to demonstrate the use of this press for one primary reason, is due to be calibrated. So yes, we want to make sure we get the crimp height and crimp depth out of this. So in order to do that, we have to send it out. The tool gets certified, it gets sent back again, and then we're good for a period of time again. Based on cycles, based on length of time, a year typically is when we'd like to see these calibrated. So I'm not going to use it because I'm afraid I might not get a good crimp out of it. But again, you would be able to twist off the lock nut, replace your die set, And here's a good example of the jaws, right? That's pretty deep. That could give you an idea of the amount of pressure that this press is going to apply to this lug. That's pretty heavy duty stuff. So this pneumatic press primarily used for heavier gauged wires. So we're going to continue moving on our way across the table, and then we get into something that's a little bit more suitable to our needs. This particular type of splice, again, barrel, yes, smaller size, used for smaller gauged wire, which we would look at something like this, which is, let me just check real quick, make sure I grab the right one, 4 gauge. This is probably atypical of what you would see in an automotive installation. You might remember a couple of series back, I had talked about um, cutting and stripping of this wire, and again, talk about stranding and amount of nicks you can have to it. This might be a better shot of the filament or paper that's between you and your cutting blade when you go ahead to strip off the insulation. So what I did prior to us going live is I stripped it back for myself. Again, this is difficult installation, but what I did was I measured it against the barrel. So I looked at the barrel. I said, hey, I need to hit this inspection hole. So I trimmed it back to the point where I can insert it and place it into the barrel. And I can see just enough. It's hard to zoom in. I know you probably can't see it at home, but I stripped it back just enough so I could see the edge of the strands. Now I'm going to be able to crimp this one for you. I'm going to try. Okay, I'm going to try. So here's the crimper that I'm going to use. As you can tell, it's much smaller in size, right? It handles smaller gauged assemblies. I'm going to go ahead and I'm going to place this into the jaws. And I'm going to start my crimp a little bit. And I'm going to start bringing it down a little bit. Okay. Now I'm going to do this in a progression. So I'm going to take my jaws out. I'm going to go one step smaller. I'm going to adjust that. And this is a nice little tool to have around. I mean, obviously it gives you an idea of the different sizes you can use. And I like progression, right? It's nice to be able to go in there and give it one shot, but really, sometimes you need the progression to make sure you get a good crimp. So I'm going to come back down into here again, start my crimp. All right, I'm going to bring the jaws down. As you can tell, I need a little assistance, right, from the table, but that'll give you an idea of that crimp. All right, I'll pull that out. Boom. There we go. All right, release the jaws. This will give you an idea of the indentations or marks in the barrel. Now, I could probably go one more size because I can tell you this will not pass a pull test. But again, I didn't want to spend a lot of time working with this one crimper, but that'll give you an idea. Yes, you can do this in the field. Remember, shrinkable tubing, right? We have to protect this. So I'm going to place this to the side. Take my barrel and place this to the side. What other options do we have when it comes to splicing? And some of you might have seen this. When you order some packages of, say, connector housings with wire leads from the OEM, sometimes you're going to get these C-clips. And this one's kind of difficult to zoom in on because they are tiny. But they're basically copper clips that require a tool to roll them and get what we would call a B crimp. Right? You roll it so that it looks like the shape of a B. Now the tooling, again, for this, because these are pretty big gauged wires, would probably be something along the lines of this. This tool could be used to crimp these C-clips. And what you would do, and you could tell maybe, I don't know, sometimes the camera's a little funky, but there's a dimple here that allows the terminal conductor wings to roll and then force itself down to create the crimp height that you're looking for. So this type of tool, this big size B crimper, and I have another one here, smaller, right? Again, right tool for the right job, is probably the two most common tools that you should probably have floating around in the shop, right? One of these two can do look at the range I have, right? I could do a lot of different crimping with this. So I'm going to put this down, put my C-clips down. The automotive industry has color-coded, again, actually the whole industry has pretty much, their butt splices to yellow, blue, and red. So I have some blue butt splices here. These are not really weatherproofed, right? This would be a simple crimp and a crimp, and then you hope that it does its best, right? I would say probably inside the vehicle you might be okay. Outside, forget about it. This is going to corrode, and you'll be replacing that splice in no time. Okay, so we do have these other uninsulated or butt splices without weatherproofing to them. So we can then move on to maybe the next phase of that, right? We want to see where the potential takes us, and that starts leading us into sealed splices. So some of these I showed a little bit earlier, and this is I like to call these micro splices. These are very nice. These come in two pieces, right? Barrel, sleeve. A lot of the automotive comes strictly barrel sleeve combination. And I had mentioned the problem with these, right? When I go to crimp this, I'm going to be sometimes cutting through this weatherproofing, which defeats the whole purpose of the splice. So it is a little bit annoying that they continue to use these, but I want you to be aware there's a better alternative, and it's quality, 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 right? So we want to think about that. And the next one would be these smaller micro, which I call micro splices or butt splices. So I'm going to do one for you, give you an idea of what that looks like, okay? So most wire leads come with a strip length to them, an area that you can use to splice onto the circuit or into the wire bundle. Now this is a little bit too long for me. I need to trim that back, otherwise I won't be able to completely insert it. Maybe I can show you what that might look like. Let's see. Right, if I did that, defect, right? There's too much wire exposed here. And even if I were to put my tubing over it, it probably wouldn't even make it. So I'm going to have to trim that back. So I'm going to trim it back. Again, this is just years of cutting, stripping wire. It gives me an idea of how far to strip it back. I'm going to reinsert it into my barrel. And I'm going to point something else out to you, which I know you're not going to be able to see, but I have a strand sticking out. Not good. All the strands need to be within the barrel. I'm losing some of the potential for this wire to carry current. Unacceptable. It's almost like having a cut strand, right? It's missing. So I want to make sure I could tuck that back in. So I'm just going to lay it real nice back into the natural twist or order. And then I'm going to come back over again with my barrel and reinsert it. Okay. And I'm going to use my inspection hole. Looks good. I'm coming over the top now with the B crimper. Again, as I mentioned, this is probably the most versatile tool you're going to have in your toolbox for repair. I'm going to use a dimple on this to create a crease in the barrel for myself. And I'm going to do it twice. To give myself a nice sound crimp. Okay. Again, things to notice: deflection, right? If I had a nice straight edge, this might be a good straight edge. I don't know if we'll be able to pick that up. Oh, by the way, I have Tom doing video for me today. Katie is out. But this might show you there's a bit of a deflection here. There is, again, specifications for everything. This amount of deflection is okay. You're going to have to trust me on that one. So I'm going to now take my other wire lead, which is here, and I'm going to strip it back. And this is key, and you might notice in the upcoming session with the Telesonic, don't forget the shrinkable tubing, right? Otherwise, you're going to have to open the circuit again just to slide this over. So as a reminder, again, practice makes perfect. Remember to slide over your tubing, okay? So I'm going to slide that over so I don't forget. I'm going to then insert my wire leads back into the barrel. There we go. I'm going to hit it with my bead crimper. Boom. Boom. Perfect, perfect, perfect. All right. Nice tug, nice tug. I'm sliding my shrinkable tubing over now, and I'm going to hit it with some heat.
I just had a question.
Yes.
Do you recommend twisting the wires before you do it, or leaving them straight?
No, very good question. The specification, and this is clearly called out, is to maintain the lay, which means if it's coming off the machine slightly twisted, you need to maintain that slight twist. Uh, and this comes when we get to soldering, which we'll talk about. That whole theory of keeping the lay kind of gets thrown out the window a little bit. Okay, but I'll explain that. That's a good question. So I'm going to go over the top now. I'm going to apply some heat, take this down, and I'm going to, oh, again, I don't know if Tom will be able to zoom in on this, but I'm going to try. Let's see what will happen. You'll know when it starts to take form. It gets very, how can I put it, mounds over, begins to bubble a little bit, create bubbles at both ends, and done. Nice splice. Again, look at these. These are, I'm just all over these splices because it's almost the diameter of the wire. How much closer can you get to putting the bundle back in the condition that it was originally manufactured to? Nice tight splice. So we have I like to call these mechanical, but they are barrel splices, open barrel. So that's a good use of that. But let's take one more look. Let's go one step further on the weatherproofing and the sealing. These are solder sleeves. There is an amount of solder, a solder ring, built into the sleeve. So it's almost a twofer, right? You get the solder, which gives you the connection you're looking for, and you get the weatherproofing ability behind it. I want to demonstrate that because they're kind of neat. So I'm going to find myself two wires here, and I'm going to go right back to this. I don't like wasting wire, so I'm going to cut this off. Okay. And I'm going to strip these back. Now, something to think about when it comes to the solder sleeve, overlap. You need overlap. So I'm going to use, let's go with this one. I'll go with the blue style, which is basically good for your 16 to 14 gauge, basically. Two, and I'm doubling it, right? Putting two wires in there. So I'm going to strip it back approximately halfway over into the other side of the sleeve, and then halfway on the other side of the solder sleeve, so it flows out from my lap joint. Okay, so let me strip that back. I'm going to strip this one back. Okay, I'm going to create my overlap. So I'm going to put my wire in there, and this is all visual at this point, right? I'm looking, I'm checking, I have pretty good overlap there. And you know what? The barrel size is pretty big. I think I might go smaller. I might have too much barrel here. So let me see what it looks like, and I'm just going to test it out. Don't know if that's true. I haven't practiced. So I'm going to go one size smaller and go to red. And I'm going to insert my wire leads in there again. And, oh, I like that. Yeah, I like that a lot. And I don't know if Tom can zoom in, but you can see I have wire lead exposed on both sides of the solder sleeve. Okay, and look at the fit. It's already looking better. It actually looked a lot better than that. Right? So I'm going to now throw some heat on here. Let's see if Tom can get a shot of that in the solder flow. I might have to turn the heat up on the gun. We'll check it out though. We'll see what happens. So these solder sleeves are rated. There is a heat specification for them. It would tell me what's required, what I should have my gun set at. And the solder sleeve is starting to take shape. You could tell it's starting to melt because it's getting that globular look to it, right? And in addition to that, the rest of the sleeve is also starting to close or seal up. Now, how do I know when it's done? The solder is going to flow through the leads. And I'll come to the camera and give you an idea of what that looks like. Tom, tell me, is that a nice shot? Can you see the solder flow? A little bit? All right, let me see if I can shut this down. I'm going to give it a time to cure or harden because it's molten, right? And since I'm just overlapping, I have it meshed, so to speak. Let's see. Is that tight enough for you, Tom? Yep. You can see from the example here how the solder has flowed across the two wire leads. Pretty neat stuff, huh? A little bit difficult to work with. Again, I'm on a bench. I'm not in the field. You know, maintaining, you need three hands, right? I'm got the gun. I've got a wire on this side. I have a wire on that side. I'm trying to manage the flow. I'm trying to manage the heat distribution. A lot going on. So, you could use them. I would recommend it if you felt the need to solder. But what we want to consider again is mechanical, right? Think about using that butt splice. All right, let's take it another step further. Let's look at what they're doing now with some of these solder sleeves. Drain wire. They're applying drain wire to your solder sleeves. Well, what's the purpose of putting a drain wire onto a solder sleeve? I want to show you what the purpose is. It's this. Shielded cable, right? This shielding, and we spoke about EMF in a couple of previous episodes about the need for it, right? It reduces EMF, the electromagnetic field generated around a wire. But what do you do with it once you capture it? It has to go somewhere. If you don't ground it, what's the purpose of the shielding? So there's a couple of different ways these get grounded now, right? Well, one of them is taking this drain wire and literally running it right to a ground stud. Another, maybe the connector itself that's on the module has a terminal assigned to it for case ground, right? This terminal, say, goes to pin 15, and pin 15 is case ground, which means it's going to dissipate through the case of the module to ground because it's usually bolted to a fender, bolted to a firewall, something along those lines. But what if you can't get close enough to it? Well, we could use a solder sleeve. In those cases, what we would do, and I'll use this one as a demonstration because I kind of already pulled that up, is I would take my shielding, which is here, I would slide it into the solder sleeve, and again, making sure that I have at least enough penetration on the sleeve so it's slightly over and under the sleeve, and then I would apply heat to this. Let me actually change my thinking on this because I want to demonstrate the wires coming out of the end of it. So let me see if I could switch. Let me switch this around a little bit. Let me try something where I have a little bit more wire lead to it. Let's go with this. So I'm going to slide my wires through. I'm going to run my sleeve down. And as you could probably see, I have it over the solder sleeve. And let me see if I have a better sleeve available for myself here. This one's a little bit small, but that's okay. I'll run it. I'm going to run it down, give you an idea again what that might look like. So as I'm starting to heat this up, the solder and the tubing is going to start to shrink and the solder is going to start to flow around my shielding. Right? Nice deep penetration, especially when it's braided like this. Woo, that's a nice mechanical contact. So I'm running that down. I'm shrinking it up. My wire leads are still sticking out. Hopefully they would be longer for you because we have to terminate it, right? So I continue to run it down. I'm applying heat. Solder's beginning to flow, and boom. Pretty good, pretty good, pretty good, pretty good. Take the heat off. That went down pretty fast. and also it helps that this bundle is pretty big. But then the idea is to take this wire now. This is now your ground. This is going to pick up all this EMF on this braided shielding here, and it's going to dissipate it to ground. Pretty convenient stuff. You'll see this on a lot of electronics, right? A lot of electronics are now looking at ways of creating solder sleeves. A great way to, again, quick route. I could tie this to a case myself if I wanted to, especially if I had no means of terminating the shielding. So solder sleeves with solder sleeves with drain wire, solder sleeve with a barrel. So this is really the most, or the better of the systems to control and get quality out of your butt splices. So moving forward, there's one other item I wanted to mention very quickly, and it's called the Jiffy connection. This one's not really used too often, but you would find it in, say, pass-through items, like the marine industry, for example. They have wires that pass through a bunch of bulkheads, and as it's passing, they need to get that wire from one circuit to another. So what they basically do is take a contact and they crimp the contact on both ends and insert it into a jiffy sleeve where it comes into one end, right? The contact comes in through the other side, they mate, dink, and then the jiffy sleeve gets shrunk down. Jiffy junction, they call it. You could Google that too, Jiffy junction, give you an idea of how and where those are used. A lot of marine industry applications for that. So we do have the opportunity for that. And also a Jiffy junction is probably just a more glorified way of calling it shrinkable tubing, right? But it does really snap in place, so you don't have to do all of this. Uh, One thing to consider too when it comes to the shrink tubing, and I want to see if I could create a defect for you, okay? Let's see, I'm going to take this wire lead. Let's see, I'll kind of strip it out a little bit, make it look kind of funky. I'll take another wire lead, take this one. All right, I'm going to make it look a little funky. I'm going to take some tubing. I just want to show you if I don't know if I'll be able to duplicate it, but I'm going to give it my best shot, okay? Let's see, I'm going to put that in there, throw some heat on it, and show you what could happen. And we spoke about this earlier. Uh, if you don't, if you have a strand that's not in place as you begin to shrink tube, and yeah, I think I created a nice defect for you. Let's see if we can get time to zoom in on that one. That is a really good defect. I'm proud of myself. I'm usually not accustomed to doing that. Do you want me to come down, Tom?
Yeah.
How's that? Yeah? Can you see the wire lead sticking out of the tubing? Because that's the key, right? I now compromised the insulation or the shrinkable tubing. This is useless. This is a very good defect. In fact, I think I might hold on to this one for future reference. And so the need, and one of our uh, uh, friends tuning in mentioned about what do you do with the stranding? Maintaining the same lay helps prevent this. So that was a very good question. You were quite a few steps ahead of me on that one, but very good, very good. Okay, again, moving along. So as we're starting to cut, strip, and crimp, again, some of the tooling required. We mentioned a heavier type of press needed for bigger barrels, bigger terminals, uh, cutters for those bigger battery cables. And let me get, this is a very nice one. I like this. This is kind of a ratcheting wire cutter. I'm going to bring it down. But look how nicely that cuts, right? Right tool for the right job. This is neat. I like that. Again, snaps open when you're finished with your cut. Moving along on tooling, so we talked about the larger types of hex crimps. We talked about the larger size of B crimps. We talked a little bit about the contacts and its ability to create be used in a jiffy junction. And then I'm going to slide a little bit over a little bit further, and we're going to start getting into some more press items. Some things that can be done in the field, some things that we would recommend that you really just kind of save for bench application, and this would be one of them. The higher the wire gauge goes, the more you should be thinking about bench top. Uh, Obviously tools are out there for you, and again, we do what we need to do, right? And so we'll do the best we can. And when we can't do that effectively in the field, then we do have to turn to some tooling, right? And in this case, this is just some pneumatic jaws. This will take me from basically a 10 gauge wire up to easily 16. Okay. Uh, I like it because, again, it gives me the crimp I need and the pull strength I need. So I'm going to go into my jaws. I'm going to lay my wire lead in place, and I'm going to hit it with some air, and bam, dimples. It's all about the dimple. Uh, Also, I have just enough insulation showing where I'm not out of limits. It would have been better if I would have stripped it a little nicer and got a little bit tighter up against the barrel, but overall, not bad. The key, again, once I do my other side, is more tubing. I'm going to come back and hit the other side. Might as well do it, right? That's what we're here for. So I'll give it another shot, see if I can get a better. Again, I'm going to watch the lay. I get a better strip on that. Yeah, that is better. And I'm using the inspection hole. And by the way, look at the fit here. This is phenomenal. You wouldn't even tell that's in your wire bundle. So make sure that you're using the correct size barrel for the correct size wire gauge you have. I'm going to hit it one more time. All right, there we go. Nice. And boom, another set of dimples. Good pull strength, and use the right size wire lead for the correct size barrel. Okay. All right, we're going to continue moving on. I want to talk about soldering. We don't recommend soldering. Still highly used. There's a lot of different applications for soldering. But when we're repairing wires, it's probably best to go with one of these systems that we just showed you. Again, you're bringing a lot of heat to the car, you're bringing a lot of heat to the wire lead, and the heat likes to transfer its way up the wire. You could run into problems with the insulation melting, right? You could run into problems with the way that the wires are meshing. You end up with big globs. More than likely, you're going to end up with a defect. Soldering's tough, but something to keep in mind that there is a standard out there also that needs to be met. We do have personnel that are J standard qualified. This is J standard 001, and J standard 1 is a very good, sound, best practices certification. So we follow this J standard, and it's difficult to follow a J standard in the field. Um, some things to think about, though, if you are determined to solder in the field, one method that we would probably recommend, and there's quite a few, but I'm just going to demonstrate it for you real quick and what one of the methods are, and then we'll talk about the others in a little bit. So one of them is called meshing, right? Where you're basically taking the wires and forcing them into each other, and they get meshed. Notice again, there's wire leads scattering everywhere. So I have to, again, make sure I get the lay that I need to put them all back in place. So that meshing can help you keep your wires intact so that you have a free hand, right? Again, I would need three hands if I wanted to do this. Again, mechanical fingers are out there too. You can try something along those lines, but this is a pretty good application for that meshing. You can lap, right? We could go over the top, which is basically what I did with the solder sleeves. We could lap. We can hook, where I would put a twist or a hook in each. And I could do that kind of quickly for you if I can, where I'm hooking one, and then I would hook it around the other, right? So we could hook. So there's a bunch of different methods to joining or holding wires in place for yourself while you're soldering. So we're going to kind of move this to a different section. If there is a lot of interest in it, we have some very qualified people in the building that can walk you through the process of a J standard, give you an idea of what that takes. And I would strongly recommend it. It's a great class, especially if you plan on doing a lot of soldering. So what's going on in the industry though? Are the OEMs working their splice points the same as we're working them in the field? They used to. We used to find a lot of this, but they've gotten away from it now. They started moving to a splice called sonic welding. So when you look at a splice, and I'll bring this one up for example, and you wonder what's underneath there, it's not a mechanical splice. It's not a barrel. It's not a butt splice. It's not even soldered. It's sonic welded. And I want to demonstrate to you sonic welding. I'm going to kind of move my way over to another position, and I'm going to introduce you quickly to Nick. Nick is our lead technician who has been checked out and qualified on a sonic welder, and he's going to demonstrate for us what a sonic weld is all about. Okay, so let's go take a look. Hey, Nick, how are you?
Good, how are you?
Good, good. It's a good morning. Okay, so Nick, what are we staring at here? What is this?
So this is a program we already made up for a ultrasonic splice. What we can see here is that we have two 16 gauges on the left and one 16 gauge wire on the right. This program is automatically already determining the math and the cross section for the splice that we don't even have to do.
Okay, great. So and I hope you folks can pick that up because Nick is basically speaking through my earpiece. So I'm hopeful that I'm close enough, but not too close, right, Nick? We know what that's all about. So, so you had to program this then, you had to put in some parameters.
Correct.
Can you give me an idea of what that might look like?
Sure. I'll flip it over into operator mode.
Okay,
Right down here we have a wizard.
okay,
Click that, splice, and then we can hit edit.
all right.
This will bring up all of our wires, our options. We can insert wires, delete wires, copy wires, anything like that. If we want to insert, we can insert a wire on the right. It'll ask us what gauge we want. We'll just pretend it's an 18 gauge. It'll ask us for a wire number. We can just do wire 1, and then it'll come up right here. If we would like to delete that, hit delete, and we'll delete that right away.
Terrific. So the program is kind of walking you through the steps of creating a good, and the terminology, I want to make sure I have this correct, is a weld nugget.
Correct. Nugget.
It's a nugget. It's a
Yes.
nugget. Okay. And then show me some parameters that
Sure.
might give us an idea of what type of quality or measuring is available to us. Make sure we're getting a good weld, right?
Correct.
Mhm.
And this is built into the system itself. It's doing all these quality checks right here. If I want to go through these real quick, this is energy per second or watts per second.
Okay. That's what we need to take out of the building
Correct.
in order to get a good sonic weld.
For
Okay.
how long? This is the frequency or amplitude.
Okay.
Because it is ultrasonic, it's using audio or frequencies instead of actual heat and pressure like a mechanical splice.
You know what, Nick? That's a very good point. I always forget that. It's not like we're welding using heat.
Correct.
We're vibrating the bejesus out of this
Yeah.
thing.
And
And
super
the
high
heat
frequency.
that's generated at a super high frequency is what's creating the heat.
Correct.
You brought up a good analogy for me. What is this like again? It's like
almost like coal and diamond. You need
Almost
the
like
right pressure, the right time, everything like that to get the right nugget.
like a coal and diamond, right? Because we're applying the correct amount of pressure over a period of time.
Correct.
Okay, very good. And then what are these other parameters that we're looking at here?
So right here,
Yeah.
this is the splice pre-height. So this is the height of all the copper before it is compressed and ultrasonic spliced.
Is there limits as to how much height I can have?
There is a limit. It's, I think right here, 10 millimeters.
Okay.
10 millimeter nugget pre-height.
Gotcha. And that's based on your wire gauge size.
Correct.
Mhm.
Correct.
Could we put in a 16, well, I don't want to do it now because I know you have a program set up, but this could handle 10 gauge wire?
10 gauge is going to, I think, up to double aught.
Double aught.
Yeah.
So we can do a
double aught.
battery cable if
Correct.
we wanted to.
Yep.
All right, terrific. So we don't even have to use a butt splice.
No.
We don't have to worry about soldering. We can bring our battery cable over here and just boom, sonic
Yep.
weld it again. That's terrific. So if something gets cut in the field, right? I mean, I suppose they could remove the battery cable. We could sonic weld it and still have the same effectiveness as the cable, new cable.
Correct.
Yeah, that's awesome. I didn't even think about that. Okay.
Right here we have the splice height after it's been welded.
Okay.
So that's what it's checking, the difference
Gotcha.
between the two.
Is it smashing it really small or is it just kind of remolding it?
it's almost like remolding it. It's taking these cylindrical copper wires and almost taking them up and flattening them and making it into a nugget, like a rectangle nugget.
Ah, yes, yes, almost like a plate.
Correct, yeah.
Yeah,
Almost like a
yeah.
plate.
So it's taking round wire and making it flat.
Yeah.
Okay. All right, very good.
Right here we have the time, how much time it's gonna take to actually weld that nugget.
Yes.
And this is all in milliseconds.
Okay.
Seconds.
Mm-hmm.
And then this is how much actual wattage we're gonna need to make that splice.
Okay, so ComEd or our electric company is really going to like us, huh?
Correct. Correct.
All right, we're going to be
Lots
pulling
of
some
money.
power.
Yeah, I was gonna say lots of
Okay,
power.
very good. Can you show us what one application might look like?
Sure, of course.
Mhm.
So I'll have one wire lead on one end.
Mhm.
These are my other two. We have a big warning right here. Remember, shrink tube first.
Shrink tube
It's
first.
also on
Yep.
this end.
Okay.
Making sure I'm going to use
Mm-hmm.
copper, keeping that same twist on it from the factory.
Yes.
Grabbing this end, making sure they're at the same length. And then in here, you're going to line these up and you want to overlap them all together.
Okay.
Want to make sure all the copper. Don't want any insulation in here either.
Right. No insulation. Again, that loose strands, right? We have to make sure everything is accounted for.
Correct. I'll hit this button right here.
Mhm. Wow, that's great. That's great. I'm sure there's a height measurement we could take if we wanted to QC that.
Correct.
Okay. And again, I don't see any loose strands. So it looks like you got everything. Oh, that's awesome. I like that. I like that a lot. And then again, you're going to heat shrink that just to make sure that it's weatherproofed.
Correct. And this
Okay.
is glue and it'll be weatherproof and waterproof.
Yeah. So every time you change a wire combination, say you're coming in from the left or you're coming in through the right, you have to adjust the program so it knows that.
Actually, you don't. As
You
long
don't.
as you can feed it in this way,
Yes.
or you could feed it in this way. I was actually going to bring that up. These quality control measures are actually built into the program.
Yes.
So it's checking the splice nugget size and everything before we can even take it out.
Oh, that's great.
So if it were to be wrong, it won't even allow you to take the splice out. A blade will come and just cut it right there
Okay.
because it's void or it's defected.
Really?
It won't even
It's
make it past that.
fantastic. Fantastic. Wow. So it won't even allow us to put a defect into the system.
No, you saw the window opened when it was completed. The
Yes.
window will stay closed and cut it. You won't even be able to take out the splice. Because it
Okay.
already knows it's bad.
Wow, that's great. That's great. So I see a lot of uses for it, and we'll go back to station, Tom. Thanks, Nick. That was really, really helpful. Appreciate that. So that's the key element, and that's what we do when we remanufacture an assembly as well. Right? As we're going through the remanufacturing process of a wire harness assembly, and we run into splices, we're going to take that circuit out, sonic weld it, and place it back in again. Quality, quality, quality. So I think that pretty much wraps up our session on soldering, butt splicing, or just call it splicing, and again, the various tools and product available to you in the field. So thank you very much. Hey, it's Friday. Have a good weekend. Let's take advantage of it. Get some work done around the house. I know my wife has a nice list going for me, so blah, but we'll get it done, and I'll see you on Monday. Thank you, and have a safe weekend.